Welcome, ladies and gentlemen, to the SME Energy and Sustainabilities webinar titled An Engineer's Role for Future Generations. I am Tamel Harbison with SME National Office, and I will be assisting today in the background if you're experiencing any technical issues. Before we get started, I would like to go over a couple housekeeping rules. You have entered the platform and mute all, but we ask that you double check your mics to make sure you are muted. And if you have any questions, we ask that you write them in the Q&A tab throughout the presentation. You are able to download today's presentation and PDH certificate in the handout section. And this webinar is being recorded, so it will be able to view later on the COI webpage. I would like to turn it over to the chair of the COI, Michelle Syke.
Great, thank you, Tamel. So very excited that you guys are able to join us again. I know we had a webinar just a couple weeks ago with PNNL, and we're super excited to have Stephen with us today. Quick ENS COI update. We will not be having a webinar next month as we're encouraging everybody to attend the virtual Capital Week that will happen the week of March 22nd. I know that there's a lot of really good panel discussions from some of the legislators that are going to be speaking with us. So please sign up. Our next webinar for the COI will happen on Thursday, April 8th at 12 p.m. It's going to be a cybersecurity presentation by the Army Corps CERL group, specifically on the 250511 cybersecurity spec. I know there's been a lot of confusion around that. So we're asking the Army Corps, the folks that wrote it, to give us some background on that for us. So that will be a joint presentation with the Resiliency COI as well as the Architectural Practice. So hopefully you'll be able to join us on April 8th. Just a reminder, JETSI will be virtual in May. Our ENS team, the abstract reviewers, provided a really good set of presentations. And so you can see there we're all over the place when it comes to sustainability, which is great. So water security, energy storage, microgrids, some discussion on artificial intelligence and HVAC humidity control. So great presentations lined up for you, so don't miss out. As a reminder, we're always looking for webinar topics. So if there's something that you would like to see this year or something that you personally would be interested in presenting to the CUI, please reach out to either me or Norm. And then last but not least, we do have an immediate opening on the steering committee for a program and webinar lead. So if this would be a position that interests you and you're motivated to take on that role, please contact me, and we look forward to welcoming you to the committee. With that, Norm, I will turn it over to you.
Thanks, Michelle, and welcome everybody. We're going to start this presentation with a couple of polls, and there we go. I'd like to see who's here and where you're from. All right, looks like we've got quite a few large businesses coming in, and we've got some small businesses and academic institutions. Super. And we have another poll. And looks like the majority of us are interested in building systems and civil infrastructure. Makes sense. So let me go to the next spot and introduce our speaker for today, Mr. Stephen Fisher from Tetra Tech. After 20 years of experience in civil and environmental engineering, Mr. Fisher took a doctoral fellowship to study sustainable urban infrastructure. Since completing his degree in 2014, he has contributed to the civil engineering profession's awareness and implementation of sustainable infrastructure through leadership in the American Society of Civil Engineers, conferences, symposia, papers, and projects at Tetra Tech. With that, I'll turn it over to you, Mr. Fisher, and off we go.
You are muted, Mr. Fisher.
Thank you, everybody, and thank you, Norm, for the introduction. I'm going to flip over to my screen and run it from there. Is everyone seeing the presentation now?
Still loading. Oh, there we go.
There we go. Okay, great. So I just want to start off by saying, ever since my PhD in 2014, I've been steeped in this and been on national committees with ASCE. That's where a lot of this information is coming from. My PhD, it was in civil engineering, but for those who are interested, it was about urban agriculture. So it was anything goes with sustainability. So this is just a real brief outline. I wanted to answer some, I think, pretty relevant questions. These are the kinds of things that I hear when you sit down with a diverse group of people, and the backgrounds are diverse, and their they may or may not have had an introduction to sustainability. So apologize if this is water under the bridge for everybody, but there is a point here that's always good to be reminded of, and that is what are we talking about when we say sustainability? I start off with the first bullet. Read that sentence for me, and when I read that, and I'll keep the whoever wrote this confidential, anonymous, but it was from let's just say marketing people in a big company wrote that sentence. When I read that, I don't know what I'm reading. I don't know what they're saying. It confuses me. It makes my brain kind of turn into the word cloud that you see to the right. So it's important to return to just pure definitions. And, sustainability and resilience are two terms that have become very loaded. But they don't have to be confusing. It's exactly what they say they are. And what will help you with the is the context. So what is sustainability? It is, carrying something on in the future. It's designing something so it will continue. It's having enough money in an endowment to keep going in perpetuity. People use the word sustainability in all kinds of contexts. Well, in our context, okay, take a guess what we mean when we say sustainability. And I'll give you a hint, there's 3 components. And they all have to happen at the same time. And that's maybe another point of departure for confusion is it's very, I'm not going to say trendy, but understandable and easy to glob onto something sustainable because it has maybe any one of those 3 components. I'll just let you ponder those. I'll get to them in the next slide, but there's the 3 things that they need to go together all the time. What is resilience? Okay, resilience is another loaded term. What do we know about resilience? From the dictionary, it's being able to rebound, to get back to where you were after some event. The flooring in your home, depending on what kind you have, might be called in a catalog or a product lineup called resilient flooring. That term is just exactly what it says it is. You build a bridge, it's resilient. This is something engineers have done. There's nothing new here. Resilience has always been with us. If an engineer designs a bridge, you want it to last. You maybe design it so that a semi can hit it and survive, or some other design condition. That's resilience. And we've been doing that for a long time. Of course, climate change has taken center stage with sort of co-opting that term, but we'll get to that. So let's get back to the core definition of sustainability. This is kind of where it all started in the big picture of things. It's called the Bruntland Commission. And that is the basis for many, many other, there's dozens, maybe hundreds of definitions by different organizations, federal agencies, nonprofits, you name it. And they all are, basically adaptations of this. So how did we get here? Well, that's the next chapter in these slides. But I'm going to keep going on the definitions of sustainability. So I mentioned, I asked you to think about what the three things that are inseparable with sustainability for our context here. And that's often been depicted in a Venn diagram. There's another helpful graphical device that I'll show you next, but there's more lingo associated with this when you show these three circles, and that is triple E or triple P, PPP. So PPP is an EPA moniker for people, planet, and profit. EEE, economy, environment, and equity. So the more fleshed out definitions are in the Venn diagram to the right here. And you can see the Venn diagram is either very helpful or very confusing. So it's trying to convey that there's a sweet spot in the middle called sustainability. And it's not that all these circles are going to be the same size and of the same importance and contributing equally. But there is a sweet spot. I would say if you move the circles around to the point of excluding this sweet spot, then you're not, in a binary sense, if you want to answer the question, are you sustainable or not, you'd say no. And some rating systems are set up that way. We'll get to that later. So I'll just pause if there's any questions here. I'll ask for questions as we go a little bit. So I'll just take any questions if there are any out there.
Before we get into that, I just wanted to make note. Could you minus the little dialogue box that's there? I think it's saying that you're sharing your screen or something like that.
Ah, gotcha. I didn't see that.
Not a problem. But I don't believe we have any questions so far. So if you want to continue.
So it's another important thing to remind yourself when you're in this context. The context, think of it as this dashed line that I drew around this Venn diagram. The thing with sustainability, this is not hard stuff. Probably, if there was something hard, the hardest part is to remember that sustainability is constantly asking you to go outside the boundary that you're in. Some of us are cookbook, cookie cutter, let's say, type of engineers where we do things over and over according to a guidance manual, and others aren't that way. So this is going to make sense to you more or less because just of who you are, your personality. And it's for all of us, I think it's constantly, because all around us we have silos, we have boundaries that are drawn around companies, a contract with a client, a product, and that's all we care about. That's all we're supposed to care about. If you go outside of that, you're out of bounds and you're improper. You're taking into account things that your client doesn't have to, doesn't want to, etc. So, but when you talk about sustainability, it does want you to. So there's a big conflict here with your charge and what you're doing and what sustainability is asking you to do. And, you know, codes of ethics and that sort of thing as an engineer or as a practitioner of some kind, you know, they want you to be cognizant of this boundary too. So when I say boundary, sustainability is way outside. And the trick is to pull in the things that matter into your boundary and take them into account. If you do that, you know, maybe we could end this webinar right now. If you do that successfully, you've nailed it. Okay. On to the next graphic device. This sometimes helps people more than a Venn diagram. It helps me more. It sends a message that if you're missing a leg, the stool will fall over. It also shows that human need, you know, basically is on the top here. You know, we're not necessarily martyrs for the environment. And I know some folks think that that's what sustainability is all about, and asceticism and etc. But not really. It's recognizing and hoping that we can all do this together in a win-win-win fashion. Now let me just pause and delve into a little bit about the legs of the stool. So the economic leg, when we say economic, there's a lot to that. It often means that your project is affordable. Something is maybe even profitable for the company. That's part of it. It's tied into equity, as you see the horizontal legs on the stool. So there's a component of profit that, of course, and this is a political you know, subject too, where equity. How is it that we have inequity? We have so few people owning a lot of money and a lot of people owning less. So there are those issues. When it comes down to jobs, sometimes comes down to who's involved, who are stakeholders, that kind of thing. That also ties into social leg, community, and health. You know, there's a direct tie. For those of you who answered civil infrastructure, there's a direct tie to the way we design infrastructure and health outcomes. So we're talking about real subtle things like levels of cortisone in a city dweller's blood through decades of living in a certain environment that planners and engineers build. And so it's big stuff. Environment, of course, is something that has, you know, in contemporary times, environmental issues is what kind of got this thing started, sustainability. And I'll get to that. We have a series of slides on the history of sustainability. So I'll move on. The next slide is a picture of a bridge to nowhere as it's come to be known. In 2000, 2 years after Hurricane Mitch, I don't know if anyone remembers this, gigantic, for the record books, maybe top 5 ever in the world, recorded history, hit Honduras. And I was on a project that went to the southern part of the country that we were concerned about DDT in women's breast milk because of the chemical releases due to the hurricane and the flooding. So one day this guy took us on a little tour, parked his car, and explained what this was. And at first it looks like, well, this is a joke, you know, is somebody really planned poorly. Well, quite the contrary. They planned probably, the Corps of Engineers designed this bridge. I guarantee you they didn't design it to withstand one of the top 5 hurricanes ever recorded. But here it is. It's still standing. The problem is the river that it went over is now gone. It went somewhere else. It's actually on the other side in the background. And of course, all the abutments and everything that ever was here is gone. So this is something, you know, from an early age, let's say, all of us, do we remember the 3 little pigs and how, you know, the first pig built a house out of straw, the second one built out of sticks, the second one built it out of bricks. Well, this was built out of bricks for sure, and it's resilient, obviously. Is it sustainable? Well, that's a totally different question. We don't know. I didn't know, and I still don't know much about what went into the materials and construction of this bridge. If it used local labor, then that would be great. But the point of this is resilience is kind of its own thing. And when we talk about resilience in the context of sustainability, it often refers to climate change. This is also a great example, even though this was 1998 and this hurricane happened. Climate change is producing more severe weather and more severe storms. So I'll move on. Any questions? Let me pause here, see if there's anybody has any questions. Okay. So wrapping up the definition phase of this presentation, let me just throw this in front of you. This is the context here is urban planning, urban sustainability, urban systems. Any one of those boxes, wastewater, stormwater, water supply, and all the products and equipment that go into those all have potentially their own sort of sustainability calculations, and are we doing things sustainably? This is handy because that sort of amorphous blob in the middle is what we deal with every time we try to do a project and talk about sustainability. This boundary cuts across all these other sectors and all these other silos, and it's inescapable. This example for cities, it shows you that whatever you're doing, whatever little project you're on, and someone's asking you to look at how sustainable it is, just remember that it's part of a system, and that system is probably part of a system of systems. So if you keep that in the back of your mind as you go through this, it'll help you relate to the goal of, designing for sustainability, measuring sustainability, all those things. Okay, I'm going to switch gears and go to sort of the history of sustainability. Like I said, in sort of contemporary society, say last 100 years, we've starting with the Industrial Revolution, let's say, man has definitely reached a point where it can pollute its way out of quality of life, certainly, and sustainability started realizing that, well, we might be pushing ourselves out of existence, not just quality of life, with all this pollution. So that's really the starting point. I think a lot of people have heard of Rachel Carson and a book she wrote called Silent Spring. And it wasn't a super scientific piece, but it was very reflecting and sort of observing of what's going on here. That was 1962. Prior to that, even, I don't know if Rachel was talking to ASCE, but ASCE started defining it and putting it in their what they call their policies and canons. And then in 1968, things started to gain some steam. This author, Garrett Hardin, wrote The Tragedy of the Commons, which recognized that we all depend on these sort of common things, that if we destroy them, it will be to our demise or destruction, or certainly reduce the quality of life for everybody. So your emissions to the atmosphere, you're allowed to do that, but you are affecting a lot of people. So that's sort of started to take hold back then. Then it's something that maybe a lot of people don't realize. Sustainability's been in the code for a long time, since the 60s, and the NEPA first was passed, and it's later been amended. But the federal government has recognized what this is. Now, implementation, if you look at 1930, 40 years, it's taken 40 years, let's say, to get where we are today, to implement these very lofty, aspirational things. So right in there, right in NEPA, it said this in 1969: restoring and maintaining environmental quality to the overall welfare and development of man. Wow, that's very aspirational. And to create and maintain conditions under which man and nature can exist in productive harmony, fulfill the social, economic, and other requirements of present and future generations of Americans. This was written before the Bruntland definition, but I'm sure you can see just right there similarities. Moving on, like I said, the Bruntland Commission report and its definition, we already went through that. And then 1997, we started to see people presenting and packaging sustainability in different ways, which are helpful. Triple bottom line. So this is for the accountants and C-suite people that are driven by profit, economic profit. So this helps those kinds of businesses and leaders relate to what we're talking about here. So there's actually now, especially, there's lots of different methodologies to convert all these sort of fuzzy things like environmental and social sustainability into actual dollars, and you can exact, a net gain or loss, along with, of course, the capital and O&M, dollar expenditures. So that continues on today. At the end of the presentation, I'll show you one that's been very successful doing this. Then I'm sure everyone's heard of LEED. This is the rating system for buildings. Really a great, thing to remember. The L in LEED is leadership, and sustainability has a lot to do with leadership. In fact, if you catch yourself doing anything with sustainability, it's probably because the owner wanted it. The owner wanted it. So, or your boss told you to, or Congress said we want it. So sustainability, it often goes right back to leadership and policy, and the business justification for it has come later. And most of the time, I'm not going to say every time, most of the time, it has proven to be the better path than to pollute or not do things sustainably. So LEED has obviously progressed and evolved tremendously, and it's driven its success is partly because of it's in a sector where market forces are at play. So a LEED building is marketable. A sustainable Federal Highway Administration bridge, maybe not so marketable because it's government, but that's why LEED has taken off so much. Not to diminish the fact that it is a very good rating system. Then in 2006, ASCE really ramped up their whole, let's just say, emphasis on sustainability in various policies, canons, initiatives like this one, Vision 2025. They just actually revised their canon again last year. This is pretty lofty stuff if you're an engineer and you're a member of ASCE, even if you're not. It's like, well, the profession wants you to do these things. And what's odd is, we still have years and years of catch up. If you look at the required curriculum of an engineering degree, a bachelor's, master's, you may or may not find sustainability in there, or at least the components of sustainability. And of course, if last time I checked, in the ASCE committee, we look at this periodically. The requirements and subject matter in the PE tests around the country, what do they have as sustainability? And it's still very lacking. So we're still catching up with that. 2007, capitalism as if the world matters. So now we're starting to tie the whole business sector into sustainability. And I'll get to that. There's a part of the presentation where I list, talk about leadership and what kind of rating systems and organizations and protocols that companies are doing to do their part for sustainability. Okay, let me just go to this topic, answer this question. How did we get here? Well, I first started out with the history of this based in environmental issues, pollution, and fish kills, and we're ruining our environment. Well, there's another reason for this, and the scope of what we call, sustainability and sustainability science today has now also incorporated what's called this sustainability quadrant, and how can this planet support what we're doing? So there's two things here. The horizontal axis, Human Development Index, which is a composite index of a lot of things, mostly about quality of life. How, developed countries, less developed countries. And then on the vertical axis, Ecological Footprint, which is also a composite metric, which basically condenses down the impact of an activity or product. On this graph, the activity or product is basically human existence on the planet and the built environment. And the sustainability quadrant is where we want to be, within all the resources available on Earth, and having a relatively, a threshold standard for acceptable standard of living. And it's not, that threshold is pretty decent. I don't know the details, but it's not like they want us to all live in huts or something. Another way to show this is by country, and these circles are individual countries. So you can see where the US and Canada are up here. We do have one of the highest standards of living, and some of the developing countries are, most of them are down here below this line, which means that they're not having a deleterious impact on the planet the way that some of the more developed countries are. Now, you can see all these countries are actually in their own little jurisdiction, their boundary. They're using more than, in other words, if the whole Earth was China, there wouldn't be enough resources to have a quality of life. That's what this is saying. If all countries were Sri Lanka, we would. So that's just a helpful way to compare what's going on. All right, so let's move over to defining. This is another one of the big questions on the outline. How do we measure sustainability? There's some key concepts before I get into greenhouse gases or anything like that. When you measure sustainability, you want it to have a defined boundary and scope. So you're only as good as what you've defined your scope to be, and whatever your metric is it measurable? Is it detectable, measurable? Is it usable information? And can others replicate the same measurement? So those are just good things for any kind of metric. And then another concept when we talk about measuring sustainability is basically two large groups of metrics. One is the use of resources. That's an easy one. That's like gallons or kilograms of a material, gallons of water, BTUs of energy, those sorts of things. That's a real easy one. And the resource use is often called extraction. Anything that we do often involves extraction of something in the environment. The other group is on the impact side, and these can be positive. All impacts are not necessarily negative, but when we talk about impacts, there's two kinds. One is midpoint, and one is endpoint. So the one that you probably hear about most are midpoint impacts. Greenhouse gas, kilogram per cubic meter of CO2, or any kind of emission is a midpoint impact. When we talk about endpoint impacts, that's much more, it pulls at your heart more, but it's much harder to measure. Endpoint impacts are, say, fish kills. So if you follow the influence of what we're doing, I have an activity, it emits something, it emits pollution, so much pollution it changes the local atmosphere so that when it rains, it's acid and lands in a lake and it ends up in fish kills, or the DDT ends up in thin bird egg shells. Those are endpoint impacts. Okay, the other key concept we measure sustainability is are you a cog in the wheel, or is this all-encompassing? So I mentioned that before. You want to be as all-encompassing as you can and own stuff. One egregious example, I'll just say, whole cities around the country, they belong to various organizations, and they report their greenhouse gas emissions in their sustainability reports, blah, blah, blah. It's entirely optional to carve out, some industry or something that's in the city boundary and sort of make an external factor. The case in point is Denver's airport. I'm in Denver. When they first did their greenhouse gas accounting, they excluded the airport, and for various reasons. I mean, there's, what percentage of the air travel is actually, all about Denver? No, it's a hub. It's people coming and going from all over. But later a decision was made, well, it's our airport. We need to take into account the whole enchilada. And they did. Of course, that made their numbers look worse. But that's a sort of, the thinking that you have to do. So what are some real ways we measure sustainability? Some examples. So I listed just a few down here. There's a methodology called life cycle assessment. That's LCA. That basically catalogs everything coming into your boundary. Maybe you're making a product, or you're building a building, or doing a road project. All the materials and what it took to get those materials. Then you build or do what you're going to do, and then you see what the emissions are, and what even end of life, and even in a circular kind of sense, called circular economy. How will it be deconstructed, disposed of, recycled, etc.? That's a life cycle assessment, and you can do all kinds of stuff with LCA. It involves, measuring resource use, water, fuel, etc. It does emissions. It does jobs. Even there's even a sub methodology called social LCA. There's another piece of lingo here, LCCA, which stands for life cycle cost analysis, and that is usually that's the present day version of asset management. I think we've all heard of asset management. It's plain good business practice. LCCA has, I'd say, if you're a large company doing what it's supposed to do, you will have done LCCA on any initiative or any product or any project. Governments do this. They project how long something's going to last. Should we spend less and replace it more often, or should we spend more and replace it less often? Good example, asphalt versus concrete on a roadway. There's some conditions and factors which lead to one answer, and other times the other answer. Indicators. So this is where I wanted to mention GRI. So another good way, it's sort of a proxy for an actual metric, like kilograms per cubic meter. Indicators, for example, rating systems and sustainability reports are also very helpful. They're oftentimes more qualitative, and they sort of normalize all the data into something that you can basically add up like a scorecard. So it makes it much easier to corral all these different sort of pieces and make some sense, especially in a comparative sense when you're looking at different options and alternatives. GRI stands for Global Reporting Institute. This is where on a corporate level, okay, we're not talking about green concrete or anything like that. We're talking about how you run your company. GRI, member companies of GRI, and you can get certified as a practitioner in reporting with GRI, and it looks at the organization, how it runs, equity with the employees, how much paper they use, how much recycling they do. Very questionable questionable tactic is taking credit for the volunteerism of their own employees on the weekends. I mean, they'll go to any length to sort of, add up all the possible sustainability factors. But nonetheless, if they agree to a third-party review, this is something even in the stock market, all these green indices and mutual funds composed of green companies, this GRI component is super important. So it's becoming pretty pervasive. Okay, any questions before we move on here? Okay, so we all know the answer. Why does sustainability matter for engineers? Okay. It matters because it's supposed to matter. I'll get to the punchline first. Someone has required it in an RFP. It's in a contract. It's in the regulations. It might be, maybe you're going off of what ASCE says, okay, your code of ethics says you should think about this. It's pretty much everywhere in what we do. It's in products. The urban planners are into it. Anything in the built environment, horizontal, vertical infrastructure. And I say horizontal, that's the typical pipes in the ground, bridges, etc., roads. Vertical is primarily buildings. So there is, it's clear that we are in this for the long haul, and we need to be good at it, lest we greenwash. This is the graphic for greenwashing, I guess. So I will discuss a little bit about drivers and leaders. So the main player in this is you. It comes down to you. I've talked to so many engineers and organizations, and it really comes down to the lowly employee in his cube. Designing something, has a good idea, has innovation, and pushing up against the status quo. So it comes down to the consultants and the hired, I can't think of another word, consultants or suppliers to inform the owners, inform the customer that this is what we do. I know some companies, engineering companies, that go through a sustainability rating on everything they do, whether it's asked for or not. They document everything as if it would. So two broad categories. One is make me do sustainability, and the other is let me do sustainability. So the make me do sustainability is probably more familiar for most of us, where it's a requirement in a contract. There's so many federal, hundreds and hundreds of guidance manuals, policies at the federal, state, local levels, in the military, etc., that are on this. There's directives from the White House, executive orders. It's all over the place. And the ultimate make me do it is the owner wants it, like I mentioned before. Then there's the other side of the coin, which is let me do sustainability. So you can see both of these relate back to you as the engineer or worker. This one, let me do sustainability is when there's something that's not being required, but that, or you have a hunch that this would be better. And it's not just win-win-win as in triple E or triple P, But the fourth dash win there, down here, is the owner, the client. They actually will also win. So that comes down to things like marketability, innovation, and being able to influence the owner and acting, like a real consultant. So those are what I view as what is driving and leading sustainability. I'll go a little bit more into that. With professional societies, of course, are leaders. Here's one example. ASCE has recently completed, and it's in the balloting phase now, an Ansi standard for sustainable design. These are the chapters in there. So this is sort of the headings. They mimic a well-known rating system, these categories. So these are the sorts of things that are coming out. You might get a contract that says design it per ANSI standard, blah, 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 and you'll open the page and it's like, oh, wow, what do they mean by this? So it's not rocket science, but you can see that sustainability isn't any one particular thing. And we're going to go off on resiliency and get an A+. You can't not think about the other things too. I mentioned that rating system. This is that rating system. This is put out by the Institute for Sustainable Infrastructure. It's called Envision. And if you had this on the wall of your office, just to glance at, that in itself is a huge tool for you to conduct, your work, to be reminded. It's very simple to just incorporate things as you go. Finally, where the rubber meets the road often are, actual legislation regulations. There's countless counties and cities that I know of now that have passed codes requiring that, putting sustainability requirements in procurement and RFPs. So this is really snowballing, if you will. And if you're working for a company that's waiting for, is reacting to a requirement in an RFP, or if you're in a company that is anticipating this, it's going to happen either way. So, final slide here before I take longer questions. Like I said, if you had that those topics and even that rating system up on your wall, just to glance at, make you think about these different components, these different aspects, these different silos. It will help you be a better designer. This is kind of the baked-in approach versus the appendage approach, I call it, where I know there's some companies that have it's sustainability is this thing you added on at the end, and the client, it's pitched to the client that way, and he rolls his eyes like, well, I don't want to pay for that. That's extra, right? Where instead we should be viewing it as embedded in every piece, every phase of the assembly line, if you will, instead of this last pass. When projects are rated, of course, that is what happens. They look back. But what do they look at? They look at the documentation that has been baked in all the different phases before. So that's the first bullet, rating. I mentioned LCA. There's a particularly popular software called SEMA Pro. For those of you who are in the materials or product end of things, LCA and this software is probably recognizable. LCI stands for Life Cycle Inventory, and those are readily available. You can actually see what a particular material has as far as resource use. How much water did it take to make that product, to make that raw material, how much emissions it has. So those are all very helpful as a tool. And then, like I mentioned, there's a few things that have been around a long time. They're just getting a new purpose in life, let's say, and that's LCCA, asset management. Of course, agency guidance. That's the first place to start if you have that and are in one of those agencies. Business case calculators, I mentioned that what's the business case and sort of the triple bottom line of things. There's particularly robust software developed by a guy named John Williams called AutoCase, which is, I believe, is capable of being integrated with AutoCAD and sort of have sustainability things graphically displayed, and you can monkey with them and do scenarios. Building information systems is part of that, so that's for the building industry. This is particularly amazing. This kind of stuff where you move a duct to somewhere else in the building and see its effect on the whole calculation. Like I said, there's hundreds of rating systems out there. Envision is one of them primarily for civil infrastructure. Of course, there's LEED, there's green lights, green roads for highways. There's literally hundreds. Lots of other triple bottom line methodologies. And then the last tool, besides the main tool, which is you, and thinking big picture and expanding the boundary, is this concept of design. What level of design? What is the design requirement? And in the context of, let's say, storms and rain events, you're designing for runoff and gutters and pipes and so on. What's the 100-year storm? We've all heard of that term, and we're coming to a point now with climate change where those numbers are pretty much meaningless. I mean, if you can have a 500-year storm 3 years in a row in Houston or something like that, you start scratching your head, going, "What good is a design parameter?" So we're leaving a regime of historical record and probability with all kinds of things, not just meteorology. And we're entering a period of risk and uncertainty. So the engineer is going to need to take into account in their design these components, risk and uncertainty, where before it was just the probability of an event happening. Now we don't know. And so risk, acceptable risk comes into play. So that's a skill set that is going to be coming out more and more. Anyway, I think that.
Okay, Stephen, yeah. We got about a minute left for questions.
Okay, I'm sorry, I didn't have a clock that I could see.
So let's run at one of the quick ones. There was a question about how is Sri Lanka so sustainable compared to other countries? What are they doing right?
It's probably a combination of their standard of living and they're blessed with very verdant, lots of forests, so they produce a lot of oxygen and uptake a lot of CO2. That's the quick answer. They're maybe lucky in that regard.
And on that same graph, how did they quantify the x-axis? What does that? Yeah, I mean the y-axis was pretty straightforward on acreage, but how's that determined on the x-axis was another question.
So I'm going back to, I think was it this figure?
Yes, I believe that's correct.
Yeah. So the Human Development Index, that's I think something put together by the World Resources Institute, if I'm correct. It might be another organization, but it's a composite index of a lot of things like water supply, housing, shelter, power, health, outcomes, education, even. So it's a composite index trying to indicate quality of life.
Okay, sounds good. Let's see. That really that hits the Q&A that came out. So that pretty much rolls up the Q&A. So I think we'll hand it back over to Michelle.
Excellent.
That's right. Hey, Tamel, we had that up there for Capital Week, right?
Yes, it looks like Michelle had to get off, but
Okay.
if for all the attendees, if you want to get in contact with Mr. Fisher, there's his contact info right there. And thank you again, Stephen, for an excellent presentation. It was great. And Norm for moderating.
PDFs are available in the handouts. PDHs, sorry.
Yes.
PDHs.
Yes. For our upcoming event is 2021 Virtual Capital Week, March 22nd through the 26th. You can find all your information related to that event on the webpage, which is samecapweek.org. You can register and find out all the good offerings that we have. With that, I would thank you guys for attending and enjoy the rest of your day.
Thank you.
Thanks. Have a good one. Thanks, Stephen.
Thank you.